Hello guys, my name is Divesh Jadwani and welcome to my YouTube channel. So guys, these days organizing your information has become a very big of a task, right? And this is what this video is all about. We are going to learn a new way of organizing your information. What do I mean by that? So I introduce you hereby the open knowledge format by Google. Now, this is a very exciting and very interesting and a very new kind of framework which is coming into the picture these days. And this will be adopted very well in the future because this is the new way of organizing your information, right? So let us dive right into this. So before understanding anything, before going anything, anywhere, let us see this particular part. What is this part? RAG. Okay, this is a basic RAG pipeline wherein we have some data which we split, which we embed and then store in a vector database. And when we go ahead, we have this particular pipeline wherein we have a user query. This user query is searched in the vector database. Relevant chunks are retrieved along with the system prompt, and the LLM is going to give us the answer. As simple as that. So this is the basic RAG pipeline, data ingestion pipeline, and data retrieval pipeline. So give me a quick yes, no. How many of you know about this? Are you already aware? Because we cannot study RAG right now. Do you know this? Cool. So here is the example in front of you. We are going to play a simple question answer thing. This is our database. Let us assume that this is our knowledge base. Instead of 5 documents, we have 5 text files. Ali went to Paris. Paris is the capital of France. France is in Europe. Ali loves to travel, and the Eiffel Tower is in Paris. How it works in a real scenario is, of course, in a real scenario, we have lot of messy documents which are interlinked to each other. We all know this, okay? So simple stuff. Okay, this is the document. Now, if the question is this, let me quickly read the question. Okay. If the question is, okay, please pay attention. I'm going to ask you the question and you have to answer it. The question is, which country Ali is in? Don't give me the answer which you know as a human. Think like RAG. Okay, think like RAG means data ingestion, forget it. Okay, data retrieval. Given a user query, which means the query is which country Ali lives in. Okay, I'm just gonna write this query. Which country Ali lives in. Okay, so sorry for this color, I hate it, but okay. This is the question, which country Ali lives in. Guys, please go ahead and tell me that if you were a RAG, what documents will you be fetching? Okay, what exact documents will you be fetching from here? Based on similarity, right? We know RAG works on similarity. So which documents you will be fetching? Okay, I can reorganize it based on your replies. Because the query contains Ali, so we will be fetching this. This will be the first one. Okay, then Ali, then 4, because Ali loves to travel. Okay, because there is the mention of word Ali, there is this similarity coming into the picture. And then we might have something like this, either this, either this, either this. So 1, 4, and then any of the order works fine. Please tell me if you agree, right? This is what it will be, right? Because we are talking about similarity. This is how a RAG would search, right? Now, but given the similarity, okay, let us say you have a hyperparameter that I only need top 2 chunks, because we have that k top chunks, right? So let us say if you have programmed it that I only want top 2 chunks. Do you think the correct information is coming in the top 2 chunks? It is not, right? Ali went to Paris and Ali loves to travel. If we go ahead and look at this, we can see that 1, 4, 2, 5 will be the order. And let us say if we have the top 2 chunks only. So given this, the response can be Paris. Okay. I'm just trying to demonstrate some scenario over here. Of course, LLMs are also smart, but we don't ask simple questions to LLM. That is why we build AI agents, right? So cool. So given this scenario, given simple vector search, the LLM might answer Paris. which is completely wrong. Why is it completely wrong? Because there is some specific flaw in this particular method of retrieval. What is that flaw? We are using simple similarity search to fetch the responses. Now, similarity is capturing the semantics. Good. It is capturing the semantics based on the question which we have given. Good. But it is missing some links over here. Don't you think that? Don't you think this is important, right? We have to tackle it, right? Now, from a lot of time, people have observed this and people have developed better techniques for that. Okay, so I'm just gonna open this notepad and I'm gonna write advanced RAG techniques. Okay, advanced RAG techniques. So what all things come under advanced RAG, right? Semantic chunking, right? Re-ranking, right? Then we have advanced type of RAGs, for example, corrective RAG and adaptive RAG and I don't know what kind of RAGs, adaptive RAGs. But again, these all work on a similar scenario, right? They all are using similarity, right? So people have been thinking about these problems from a long time, and they have tried to come up with different solution. One of the solution you might already know about is vectorless RAG. See, vectorless RAG. What does this mean? Remove this part of vector. Okay. Then you have something called as graph RAG, right? Why do we need graph RAG? So that we can store this data in form of graphical representations instead of just storing it in vectors. Then of course, graph RAG will have some what do you say? Graph RAG will have some drawbacks. Vectorless RAG will have drawbacks. So people are always recommending go for hybrid RAGs, right? And hybrid RAG will be a combination of graph RAG and traditional RAG. And vectorless RAG is also used in combination with graph RAG and traditional RAG and vectorless RAG. This is the kind of hybrids we are coming towards with. Again, to solve that particular problem, the similarity problem. Yes, similarity is great. Similarity is cheap, and similarity is scalable. Please don't forget that. The biggest reason, the biggest offering which vector databases gives us is scalability over huge chunks of data. Bring in whatever chunks you want, we will take care of it. Okay, so there was some framework Pipecat, right? If for making voice agents, right? You can go and read this. So Pipecat is a framework, just how we have LangChain to make LLMs, AI agents. Similarly, Pipecat is for making voice AI agents. See, Pipecat is an open source ecosystem for building voice and multimodal AI agents. So Pipecat is used to help to make those voice calling agents and customer service agents, all those kind of agents. Okay. Now Pipecat uses a memory layer. Okay, I will not go in depth. I will have to search for it. Okay, somewhere to see if I'm able to find it. Okay, let me not waste time over here. Pipecat uses a memory layer in two phases. Pipecat uses vector memory layer and graph memory layer. Similarly, if you talk about LangMem, okay, again memory layer. LangMem also offers us a way to use vector related memory and graph related memory. So we know that people are thinking about this from a long time, and to solve this they have been coming with different concepts. One of this is page index. Let me show you this page index thing as well. Okay, let me show you this page index thing, right? Page index, if I tell that summarize this document, whatever chat I give, it is gonna give me a graph. Okay, see, it is gonna give me a graph that I fetched these things. If I open it, let me see, where can I open it from? All right, something like this. Let me take this, which I recently thought. Yeah, see, graphical structure. We are able to see some graphical structure in this vectorless RAG thing. Okay, so we know this thing exists. Solutions are coming up. Now, coming to the topic. OKF. What is OKF? Introducing the open knowledge format by Google. So Google has developed it. Of course, it's a good thing. It's a good, it's a good contribution to the community. And let us read this. Okay. Reading is very important, and reading the documentation is gonna keep you updated. Okay. So I'm reading this. Read it with me. I will also share this. Don't worry. See, I'm sharing this. As foundation models continue to improve, the lack of relevant context often limits what they can do. Especially they are used to build agentic systems. When especially they are used to build agentic systems. While these models can help you write code, summarize documents, analyze dataset, they still need right information to produce accurate and actionable results, right? So open knowledge format is something which is trying to solve the same kind of problem we are talking about. Now, is the problem clear? Give me a quick yes or no so that we can see the solution. Thanks, guys. All right. Thanks for the response. Now, let us quickly look at the solution. What is the solution like? So, we remember this. Ali went to Paris, Paris the capital. What if we organize this information? I am organizing this information into a graph-like structure. So, check this out. Better graph or OKF kind of structure. We will talk about what is that OKF kind of structure. So Ali went to Paris. Some relationship is being built. Paris is capital of France. Again, a new relationship. Again, Paris has Eiffel Tower. France is part of Europe. Okay, so we got better information from here. And now if we go ahead and look at this, what country is Ali in? So it is going to do traversing, which means again searching through the graph database is called traversing. And the response we are going to see is Ali, Paris, France. So there is some link being established because of the kind of graphical structure we made. Okay, Ali, Paris, France. And that is how we get the correct answer. And this was the solution. Just organize the information or retrieve the information in a different way. Okay, but again, like I said, whatever solutions people are coming up with, they have their own problems. Okay, now this also has some problem. Let us look at the sentences now. Ali went to Paris. Paris is capital. France is Europe. Ali loves to travel, and the Eiffel Tower is in Paris. Okay. Now, if I see, I can establish links between this sentence, this sentence, this sentence, and this sentence as well, because these all are identical. And see, Paris is matching to Paris. Ali is matching to, Ali is matching here, no worries. But Paris is matching to France. Paris is matching to this Eiffel Tower. And France is matching with Europe. So these are the kind of links established. Okay, the graph which is being established. There was something which was not captured. Ali loves to travel. Okay, now if I ask a question that, hey, what does Ali love? Okay, what does Ali love? So when this tries to traverse, so Paris has Europe, there was no such thing as loves to travel in this particular Ali related information. Yes, I know it will be established, but I'm just trying to pick up some example. Okay, so this information loves to travel is not in the graph, which is totally missed. And because of this information is not in the graph, it could not answer, right? So nothing is perfect in this world. Simple vector retrieval is not perfect. It is very good, but not perfect. Graph retrieval is also good, but not perfect. Okay, there is something which graph misses, there is something which vector misses. But similarly, if we do the same question for a simple RAG, okay, simple vector related question, Ali loves to travel will be the right sentence retrieved, right? So the answer is hybrid systems. Okay, go for hybrid systems. Graph part, okay, the graph kind of things which needs the graph kind of structures that can be managed, and the vector related structure, they can be managed, which means now if we try to modify this particular pipeline, question retrieval will come from two places, pipeline will be the same. Now only this retrieval part will be divided into two parts. One will be a graph based retrieval and second will be a vector related retrieval. Okay. Yeah, vector means semantics. So yeah, Sohil, you are absolutely correct. Organize the graph format and then retrieve the information. Correct. We will talk about it. All right. People, problem clear, solution clear. Okay, this was not the quite the solution, but is it clear? Okay. Cool. Let us look at the use case now. Let us look at the use case. Now I'm gonna show you some data over here. Okay, let me show you some data. I am pulling up that data for you. So docs and just give me a minute. Raw data and yeah. This is the data, guys. This is the data. Let us look at this data. Okay. Oops. What is this data like? These are some MD files. Okay. I will do everything. Let me go with my own flow. Everything I will be covering. Okay. I'm just showing you some data. And let me show you this data as well. See. For computer vision, you need to learn deep learning. Okay. For deep learning, you need to learn statistics, but nothing of that sort is mentioned over here. Okay. For deep learning, you need to learn machine learning, and for machine learning, you need to learn statistics and Python. Okay. Nothing of that sort is mentioned over here. If I go to, data science, it is mentioned that covers end-to-end flow, data analytics, etc., which means information is related and information is not related as well. So what I'm going to do is instead of confusing you guys, let me show you the demo instead. Okay, basic RAG demo. So the simple question is, you can read the question, what is the path from computer vision to Python? I mean, what is the path from Python to computer vision, which means how are you supposed to reach to the computer vision? Okay, and when I run this query, see what are the relevant chunks I get. Computer vision, NLP. Why NLP? Because there is some reference of computer vision over there. So we also understand that we are also fetching some irrelevant information over here, but that we can definitely resolve with re-ranking techniques. Okay, then Python prerequisites. So what we have totally missed over here is deep learning. Okay, deep learning over here. So the curriculum leads from an introductory Python course, Python foundations, deep learning, computer vision. Okay. So yes, that is there. There is no statistics mentioned over here. So see what it is mentioning. Learn Python, learn deep learning, learn computer vision. This is the answer retrieved by a normal RAG. We have used re-ranking internally, and that is how the response is better. Okay. So that is how Python is coming into the picture, even though Python is last, because we have implemented re-ranking. Now, we'll see the OKF retrieval, open knowledge format retrieval. And here, if I have passed the same question, what is the path from Python to computer vision? Okay. Let us look at this response. Python, statistics, machine learning, deep learning, computer vision, data science, AI. All of this is mentioned, all of this is fetched properly. And if we look at the response now, Python, statistics, ML, deep learning, computer vision. This is the right kind of output rather than this. Okay, which means this failed to answer, right? This failed to answer, and this was successful in capturing this kind of information. Okay, and see the graph internally looks something like this, like I was showing you the nodes and the relationships, and we can see all the relationships, and the graph is the graph RAG was able to fetch the information. This was some graph RAG kind of thing coming into action. Okay, I'm just using that word graph RAG, don't confuse yourself. It is the same thing. Like I said, I have just divided this retrieval pipeline into two parts. First part is normal vector related part, and second one is OKF information. So both of those are retrieving and giving the information for the hybrid. Okay, now again, this was not hybrid. Okay, there was some sentence there was this question which RAG answers, but OKF fails. Why? Because this is the same part that Ali loves to travel, which means this was not captured by our OKF. So let me show you. If I ask this particular question, this is a live demo, by the way, my systems are running behind. What is the minimum attendance? No, GraphRag and OKF are not related. I was just using that word. My bad. Let us understand the demo. I am coming to everything. I have not yet started. I am just showing the demos now. What is the minimum attendance required to sit final exams? This is not related anywhere to our data. Okay. Now, if this is not related anywhere to our, what do you say, to AI, deep learning, machine learning. Although this is in our data. Okay. If I show you, all right, it is on some another tab. Just understand what I'm saying. There is some data regarding the attendance. Okay, let me run it. I will show you what is the retrieved documents. There is some data regarding the attendance, but it is not linked anywhere to deep learning AI, right? Because they are not interlinked. So see what it has linked: curriculum rules, project guidelines, Python prerequisites, and ML. So these are the top 2 chunks retrieved. Now look at the response. The minimum attendance required to sit final exam is 75%, which is correct. Okay. But if I ask this same question to this guy, okay, who was first successful in that question, now this will fail over here. Let me show you. See, the provided knowledge about Python concept does not include any information regarding attendance and policies. So it was not able to fetch from this particular information. Okay, so that is why we need a graph rag. Okay, sorry, not graph rag, hybrid rag. Okay, now this hybrid rag will pass this question and will pass that computer vision question as well. So, so let me run this. See, what is the minimum attendance required? So you can see that it has properly fetched on the left hand side. It has properly fetched these questions, and on the right hand side it has wrongly fetched. So the correct answer is given. Again, what is the path? If I ask this, what is the path to computer vision from machine learning? No problem. From machine learning, let us skip Python. Let us see what kind of response do we get. This time this guy will fetch better information. Okay. See, again this guy fetched NLP, which is not good. Machine learning, deep learning, and the correct answer is you will get whatever answer. Okay. Machine learning, deep learning, and then computer vision. Okay, this is the path. So yes, that was it regarding the demonstrations. That was it setting the context. I showed you 2 demonstrations. First was regarding this particular documents, and then I showed you some another example wherein we had some AI deep learning related content, and it also had, so that was a college database basically. I will show you that database again, don't worry. And these were the 2 demonstrations. I am also sharing the GitHub link. I have made this. Okay. This is the whole system. I have made it. After the class, I will also update it with new things. But this is basically everything which was running, the applications which were running, all the 3 apps. Guys, is the context clear about what we are going to study so that I can start teaching you that? Did you like the, so Krishna is saying, so the hybrid gives the relevant information rather than irrelevant from lone RAG systems. Krishna, you're absolutely correct. Could you tell about how to confusion result from both? Could you tell me more about how to confusion result from both? I was not clear with that question. Sriram is asking, OKF and graph rag are the same? No, they are not the same. I will come to that. Where is deep learning coming from when it is not retrieved in chunks? It was retrieved in chunks. Okay. How OKF is different from Colpally? I'm not sure what Colpally is, but yeah. Cool people, should we go ahead? Should we go about how all of this thing started? We have a lot of time. Chill out. Okay. How do you merge both results? Okay. How do you merge both results from OKF and vector? We just get the chunks, concatenate the chunks and pass it to the LLM, just how we traditionally do. Can you tell again what were the exact 2 failure in the different cases? See, in simple words, first we try to, here we try to ask to the simple RAG that, where does Ali live in? So it failed and gave the answer as Paris, wherein it was the France. And then we asked another question that to this organized information that, what does Ali love? Ali loves to travel, but it failed. Let us just see this right now. So we remember this as foundational model continue to improve the lack of relevant context, produce accurate actionable results. We are working on this. That's why today we are introducing the open knowledge format, an open specification that formalizes the LLM Wiki pattern into a portable, interoperable format. This is the main line. That is why today we are introducing the open knowledge format, an open specification that formalizes the LLM Wiki pattern into a portable and interoperable format. This is a vendor neutral agent and human friendly standard for representing the metadata context and curated for modern AI systems. Okay, I am just explaining you what does this mean. Open knowledge is a format to organize your data which is inspired by the LLM Wiki format. I will talk about LLM Wiki format. Okay, let us understand these words into a portable, which means we can use this particular format from system to system. Okay, interoperable format, which means we can pass this same kind of organization to all the tools which we use for our AI agents. This is a vendor neutral agent and human friendly standard, which means the bottom line is we organize the data in MD files. I'm just revealing that thing right now. This format which you're talking about, open knowledge format, it is organizing the data in MD files. Now, MD files are such files which human are also able to read easily. And if you are using Cloud Code, you might know that Cloud Code and any other coding agents are working best on MD files. Okay, so that is the whole purpose. Now I am coming to this LLM Wiki part. How many of you know this LLM Wiki part? Okay, just quickly tell me how many of you know this LLM Wiki part? No worries. Okay, we all know this guy. We all know this guy, right? Cool. So what happened is he now we know that this guy is kind of a trendsetter in our AI game, right? He is posting some tweet and people are starting to make a big hype about it, and actually they are worth it as well. Okay, so let us read this now. Let us read this. We are not going anywhere. LLM knowledge bases. Something I'm finding very useful recently using LLMs to build personal knowledge bases. Using LLMs to build personal knowledge bases for various topics of research interest. In this way, a large fraction of my recent token throughput is going less into manipulating code and more into manipulating knowledge. So people, we all use Cloud Code. Okay, we all use Cloud Code and we all have huge amounts of data files which we are working with Cloud Code back and forth. These can be MD files regarding your code base which you are programming, or this can be some docs, PPTs, PDFs, or whatever kind of data you are working with. Every time you work with, you have some messy data. Now, whenever you ask your Claude agent or some agent or even your RAG retrieval system to search for it, it will always do a fresh search every time you ask it to search for it. Of course, because memory does not apply over here. Okay, memory layer is for conversational part, but not for the retrieval part. So please tell me if you agree on this particular line, because this is very important, that every time you are trying to search something, even with your Cloud Code in your own directory and even with your RAG system, every time it is doing a fresh search. Okay, even that system which I was showing you, every time it was doing a fresh search. Okay, so we agree on that part. And by doing that fresh search, yes, OK is Google's version of LLM Wiki protocol. Yes, caching is another part, but I'm trying to tell you about that every time it is doing a fresh search. Okay, now what this guy did was, this guy, he had a lot of data he was working with. See, he might have mentioned over here articles, papers, reports, data set, images. He had a lot of data he was working with, and he had mentioned around 100 articles, 400 keywords. Okay, what he did was he tried to ask his agent to organize the data in a way that every time you are fetching the data, you will fetch it faster instead of hitting a new fresh search always. Okay, because every time it was hitting a new fresh search, it was reading the entire files. This is what Claude Code does. Okay, and RAG also retrieves chunks every time. But now, if you are organizing this information in a graph-like structure, you will automatically bounce to those parts which are important. This means now every time you will do a search, this will not be a fresh search. You will be searching in your organized information, and that is how you find your things faster. Okay. Similarly, this is the main point, that you find your information faster. Okay. This is not graph rack. This is organized in MD files. I will show you how does that exactly look. So what he did was, he did this and information was organized in a better way, which even a simple Python program was able to fetch, and even Claude Code was fetching properly. Okay. Now, Gaurav, that was a nice joke. Okay. Now we are going ahead. Okay. So this guy gave us a MD file. See, this is the MD file. I'm sharing it. Okay. This is the MD file. He told that a pattern for building personal knowledge bases using LLMs. Okay. A pattern for building personal knowledge bases for LLMs. So which means you can use this pattern, the way of organizing information, and you can organize your information so that you don't do a fresh search every time. Okay. And here instructions are mentioned, just like a skill file, skill file, instructions are mentioned. Okay. That give these instructions to your Claude Code, give your data, and it will organize your information. Do you want to see that in action? Should we do it? Let's do it. Okay. I will take some raw data and I will take this MD file. I will open my Claude Code in front of you. I will ask it to do the thing. Okay. So great. That is, okay. Jatin is asking, since it is an operating on MD files, then what about multimodality? Yes, there is also a way of doing that. We capture using, matplotlib files and parsing. There is something. Okay. When you read this, you will know. Okay. You read this and you will know. Now what I will do, I have this. I have kept this for you already because I know you guys will be excited. This is my raw data. Check out this data. This is the same data on top of which I showed you the RAG demonstration. AI, computer vision, curriculum rules, see, unrelated file, data science, deep learning, statistics, Python, project guidelines, NLP, and machine learning. Okay. This is what? This is data files of a college. Okay. College database. And this is the LLM Wiki, which I just downloaded from the gist I have shared. Now, if I open my Claude Code, okay. I am opening my Claude Code now. So let me go here. Okay. You can use Claude Code or any other agent which you use. See what kind of simple prompt I will give. Read this. I'm going to zoom it in real much. Read this llmwiki.md and organize my raw information. Okay. My raw data. One simple line and see what will happen. Okay. Because instructions are mentioned in this LLM Wiki. Claude will read it and Claude will automatically make this into a processed data. We will see how that data looks like. Okay. This will be called the LLM Wiki pattern. Now, what Google did was, Google loved this idea and Google took one step ahead. Okay, I'm going here until that thing is working. That's why today we are introducing open knowledge format that formalizes LLM Wiki pattern, which we will see it is running, okay, into a portable interoperable format. So what happens is, now LLM Wiki will analyze according to himself. Okay, I mean the Claude, according to Claude, it will analyze and it will start making this data. Okay, what is Wiki? People are asking. Wiki is nothing, just a list of MD files. Okay, now Claude is organizing this data and it will be up to Claude that what kind of header information it will keep. Header information as in, let us say you have a gift box, you are giving it to someone, you are applying a sticker that gift from Divesh. So that is what is the header information. Claude will decide what kind of header information we should have. What is different over here? Google says that there will be a specified pattern of header. Okay. There will be a specified header pattern. Let me see if they have mentioned it over here. Okay. All right. They have not mentioned over here. Okay, they have mentioned over here. There will be a type, there will be a title, there will be description. Okay, this is the LLM Wiki one. Let us see if they have given there. Okay, they have not given there, but they have explained this explicitly in their GitHub. Okay, so if you will be wondering, where did I study this OKF from? I studied this OKF from GitHub of Google. Okay, they have given this link somewhere. Let me see, where is their link? Somewhere they have given this link, but no worries. This is their GitHub. Okay, I'm sharing both of these links, this link and this link. Okay, let us go through these links. Now, open knowledge format, it is telling you how things work and motivation and how they made it, etc. This is a 2.0 version, by the way. And you know, they have a dedicated format. I will show you now. Okay, see, this is the dedicated format. OKF can reorganize documents multimodal. Yes. So see, I will show you the LLM Wiki part as well. Let me see if this is done. It is still working. LLM Wiki will organize in its own way. So see, this is how it will do: type, title, description, resource, tags, timestamp. Okay. But OKF, Google OKF, they went a step ahead and they said there will be a standard format. Okay. Type, title, description, resource, and tags. This tags helps you for traversal. Okay, in this tags you will be mentioning computer vision, etc, etc. If I show you my repo, and I have mentioned docs over here, and I have mentioned each and every part. See, project overview, why LLM Wiki, what is OKF, problems with tradition, everything I have mentioned. Let us look at the data set. Okay, let me see if it is mentioned over here somewhere. Okay, it is not. Let me see if it is. Okay, see, type, title. So type is a concept, which means we are talking about a concept. Concepts means one particular file. Okay, concept means one particular file. Title, deep learning. Description, neural network based machine learning methods. Tags, AI ML neural network. So this is how it is traversing from one file to another. And source. And here down below, it is also for prerequisites, let us say machine learning. It is also giving the source of machine learning, so it can bounce onto machine learning. And this is how internally the graphical structure is being built. And we can easily take these MD files. So I'm showing you how the process data also looks like. Okay. Data, we have raw data and we have OKF data. So I will open raw data first. AI source document, overview, prerequisites, etc. This is the raw data. If I go to OKF data, and concepts means a single file, I'm opening it. Single file, I'm opening it. See, type concept. So if I go to code, see, type concept, title artificial intelligence, description, tags is AI and foundations. Source, this is the source, and related concepts, ML and deep learning. Okay, and it is also giving the source so that the agent can bounce onto these particular sources. Okay, this is how it is building. Now understand how this works. Every time there is a new source of data, okay, it will be properly organized within this. Okay, it will be properly organized within this, which means, let us say if we have a new concept, agentic AI. Okay, so that agentic AI tag will come directly in artificial intelligence, like this, agentic AI, new tag. And it will directly, create a connection like that, the traversal part, like this, what I was showing you. Like this, it will automatically add a new link to the new document which is added. Okay, and a simple Python program can do it. This traversal, this searching which I'm talking about, simple Python program can do it. We don't need, vector search. Vector search is cheap, but it is costing you something. But this traversal which we are doing, that is completely free of cost. Python programs can do this traversal depending upon the graphs. Okay, no, Vecha, OKF does not save data in graphs. OKF saves data in MD format. It is right in front of you. Okay, this is how it is storing. We can take these MD formats and convert it into a graph. Currently, I have not done it because my data is only 8 MD files. But if you have 8,000 MD files, then you will take this into a graph. Okay, then you will make a data pipeline for graph. Okay, so cool. Let us look at it. It is done, and let us look at what this pattern is made by LLM Wiki. Okay, see administrative courses, no worries. Okay, if I go inside this courses, okay, now see, it was called concepts by Google, it is called courses by LLM Wiki. Now why it is called courses by LLM Wiki? Because LLM Wiki is much more personalized for you, one person who is using it. And that is the problem Google found out. Google thought that cool, idea is very good, but I need to use this particular technique in a better way. And what Google did is, Google consolidated. I mean, Google went a step ahead and they said that we will have a standard format. We will not have multiple formats depending upon use case to use case. Why? Because if I will be handing off my code base to another Claude agent, I will have to tell my Claude agent that this is this and this is that. But if I just hand off that OKF format to some another agent, that agent will know how to use OKF once we give the OKF skill. Okay, here we'll have to create a separate MD to explain this. Understand? Now see how it is made. If I open this AI, okay, I will explain this LLM Wiki. Let us have a look at it. Okay, I am keeping this in front of you and I am keeping this in front of you. Concepts means a single page. Look at this code. Here, type, course, code, something, title, AI, prerequisites, something, source, something, leads to something. So the idea of Andre was the same. I want to do traversal in my MD files. Okay. Yes, Krishna, you are right. How to generate this OKF file? So just how I got this particular thing, just how I took this from, okay, Sudhir, I will come to your question right after this. Let me not break the flow. Let me show the comparison first, how to generate that. So cool. LLM Wiki we got from Andre. Okay, we got from Andre. OKF we will get from Google. They have given this spec.md. Just how we have llmwiki.md, Google has given us spec.md to generate these things, OKF. Okay, now LLM Wiki has made something like this: type, course, title, leads to, source, etc. If I just open something else, machine learning, okay, course, machine learning, leads to deep learning. See, links are created. Source, raw machine learning, MD, and here also it is organized properly. Okay, this is good. This is good, but this is better. Okay, let me show you how this is better. So type, concept, title, AI, description, this, tags, AI foundation, source, this. Okay, and even in the related, we have something called as related concepts here, wherein we are giving the source properly. Okay, now if I go to other machine learning thing which I opened, so see, machine learning has tags, AI and ML. Now what I'm trying to tell you is, understand this part, please focus. Remember, I was saying that this is made by Andre. Okay, this is the LLM Wiki.md. This is made by Andre. I will have to write a program when, so I told you that traversing in this is costless. There is no cost in traversing from one MD file to another. We are just going to look for tags. Okay, and similar kind of tags information is going to be passed as context, which means the retrieval is free. Okay, when we will be writing a retrieval code for this LLM Wiki.md, we will have to write a specific logic from use case to use case, which means this is my college syllabus. So I will have to write a program for my college syllabus. Let us say if I have some other data, what do you say, manufacturing data. So if I use this LLM Wiki, data is organized, but I will have to write a specific logic again for that manufacturing, because here Claude is the one to decide what the organization is going to look like. These things, type, title, the organization, Claude decides how it is going to look like. But here title, description, tag, source, this is standardized by Google OKF, and Google OKF decides that this is going to be a standard formatter. So this is what it means from portable and interoperable. See, where is it? Let me go here. It is saying portable, which means we can say take the same block of code and give it to another program and it will work absolutely fine. We don't have to write different configurations for our different code bases. Okay, I'm gonna repeat and I'm gonna write. Okay, how is LLM Wiki? This is the main highlight of the class. How is LLM Wiki different from OKF? We don't have to write different configuration for retrieval logic from code base to code base. Okay, from code base to code base. Now we don't have to write different logic from code base to code base. This means portable. Okay, and now what does interoperable means? Which means if we have multiple tools, right, we make tools for our AI agents. So all the tools can use one Python program for retrieval, similar Python program for retrieval, interoperable. And that can be same used by our Claude agent as well, our CLI agents. Let me be very specific, CLI agents as well. And this is what means interoperable. Now I'm telling you what is happening earlier. Now I'm summarizing everything we have studied. Please pay attention if you don't know. We are talking about problem with retrieval pipeline with respect to vector RAG. Okay, when we are using vectors, there is a problem that we lose context. Why do we lose context? Because yes, Gaurav, that can be scalable. Yes. Okay, we lose context because, okay, let me forget, I just lost the link. We lose context because we are focusing more on semantics and we are working on similarity based concepts. Okay, now the solution is OKF, organize data in a better way. Okay, this is the solution. All right, cool. I think I lost the link, guys. Don't worry. We are cool over here. Organize the data in just a better way, in a standard format, which is portable and interoperable. Okay, interoperable. So we are eliminating the vector retrieval part. Okay, so people, let me take a pause and ask you, are you cool with this particular information? Did you understand all this, what I'm talking about? I know I totally messed up by summarizing. I just got distracted with some other question, you know. That's one of the drawbacks, but no worries. Okay. Okay. Andre Karapathy was working with a lot of data. He wanted a way to organize it. So he wrote a MD file to give his coding agent or Claude agent that, hey, organize my data in a specific format. It worked only for him. He shared this with the community that, hey, people, I found something new. You all try it. Organize your information, live your life. Okay. People started to do it and it was working fine for them. And, information was organized in a better way. But the problem was that it was only for that particular person who was using that. Okay. Claude agent will decide what will be the format for the contextual information. I mean this part. Okay. The header part, I was talking about the header. When you wrap a gift, you write a header, right? So this header was decided by Claude for that particular use case to use case. Now, what OKF did, OKF went a step ahead and they said that this format which you are saying, this format, we will decide that format, and we will keep it a standard format so that everyone who uses it can be portable, can be interoperable. Okay, let me take a few questions now. So yes, but more in depth for how vector search not good and how OKF good. Okay, Uday, I will come to you. So vector search is missing context. Okay, vector search is missing context, which is not similar but yet important. And OKF is capturing context with the traversal part. Okay. Now, so it's dirt cheap and free to use OKF. Yes, it is open source. It is nothing, just a MD file. Guys, this is the MD file. Just how, see, just how, where is it? Just how I used LLM Wiki.md, I can use this Google specs.md. See, OKF spec.md. I can use this spec.md. See, I'm doing it right in front of you. Okay. Let me take this. Let me go back. Let me paste this. Okay. Now I'm going here and I'm telling it, now use at spec.md to organize my data in other folder so I can compare. Okay. And this is how exactly I have done the data processing for my code. And you know, more interesting part, if I show you the code base, okay, if I show you my code base over here, let it run, it will do its part, and I will show you the difference as well. That is not a big deal. If I show you this, of course, I have built this entire thing with Claude. Okay, if I show you the Claude context file, Claude build instruction, see what I've written. You are the lead engineer, build classroom ready, etc., etc. Use the current specification as reference. Use Google's official OKF library. Use Google announcement for getting the context and make the app. Okay, there was more things involved, but I have directly passed the Google, Google repositories, and now it is running. I will show you. Apart from that, there is another link over here which I have already shared. I will share again. This gives us examples. Google has given us samples also, that how it is used. Okay. Yeah, how it is different from vectorless RAG. So vectorless RAG is internally building those graphical, states. Internally, it is building those binary tree concepts. Here, we are building MD files, and in which MD files we are giving links to our data. Okay, let me show you that. Okay, I think we have already seen that, but one last time I will show you. Okay, OKF and concepts, and see, this is the links we are creating. Okay, and in vectorless RAG, binary trees will be created. Okay, so Parth is asking, does using OKF increase the latency since we have to fetch the data? Parth, your answer will be answered. Your question will be answered when I show you the evaluation part. And latency will be less than generation, and to build OKF we have to use RAG as much as possible to again. Okay, let me read it again. Latency will be less than generation. Yes, of course. And to build OKF we have to use RAG as much as possible to again knowledge, or it is just organizing data in a proper way. Okay, so it is just organizing the data in a proper way so that you can retrieve the data in a proper way. All right. Now let us try that one more time, guys. I just hope it works. Okay. Let me go to some another region. Let me open it so that I can show you the evaluations of my application. Okay. Guys, life's good, life's amazing again. Okay, that panic was worth it. Now let us see. I was doing this 11 hours ago. I am opening this tracing, Langsmith tracing. We all know this. Okay, and this is not what I was supposed to show you. I was supposed to show you evaluations. Now evaluations code is also present, guys, please. Okay, this is my repository. Evaluations code is also present in the SRC. Let me show you Langsmith eval. Okay, Langsmith eval. In the docs, if you go and see which evaluation methods are used, so we have used different metrics: groundedness, retrieval relevance, correctness. Okay, I've used all these different things, helpfulness, so that you can read and understand. I will not put time in there, but if you understand evaluations, I'm showing you the evaluations. So are you ready to see it, people? And are you with me, people? Because we are jumping onto a very important part. Okay, when you show evals, are you able to compare OKF? No, I'm able to compare OKF and the hybrid system and the traditional RAG. When you are organizing, does it utilizes database if there are large amounts of data? Yes. Okay. Latency is high, as latency will less as we are not retrieving it again. Yes. Okay. So if OKF retrieval is done by LLM only by seeing toc.md files, no. Okay. It is not like that. Index is built. I will show you the index. Can we convert IEEE papers? Yes. I do that. I have done that. I'm also into research, Sriram. Retrieval is done. Okay. As you told, graph for large data, then if we combine OKF, then what about the computation part? We will see that. That is why we are doing evaluations. If we use dense plus sparse search, then re-rank. Yes, Uday, we will get good results, but some context will be lost, right? One thing, someday, sometime, something we will lose. That is why we want to be more accurate. People want to be very accurate. Okay. Cool, people. I am going to press this button in 5, 4, 3, 2, 1. Okay. Everything will be clear. Okay. I have used 7 questions. These are the results. Okay. For the people who were trying to see the latency, you can see the latency as well. Okay. I will come to this. Let us open the questions. Which were the questions used? So I think here 7 questions. I have evaluated this on only 7 questions, but 7 questions was all. Okay. Let me see where are the questions. Okay. Questions will be somewhere. I just want to pull that up. Just give me 1 second. Sorry for that disruption problems. The data set. Okay. Yes, I have it, guys. I'm sharing this with you. You can read which all, how evaluation is happening. I have these 7 questions. I have tested these 7 questions on my 3 systems. System number 1, basic RAG. System number 2, OKF RAG, wherein we are retrieving information from the OKF organized data, and hybrid RAG, wherein we are retrieving information from both vector evidence and OKF evidence. Okay. So cool, guys. Let me go here. Let me go to the evaluation page finally. And let us look at the metrics now. And let us look at here basically. We ran 7 questions. Okay. Let us see these. This is basic RAG, this is OKF RAG, and this is hybrid RAG. So in 7 questions, these are the metrics. Let us look at it. Correctness was 76. In OKF, correctness was 86, which means, did you give the correct answer? Okay, if people are concerned. Did you give the correct answer? So in traditional system, it was 76. In OKF system, it was 86. And in the hybrid system, we increased it by 99. Okay. Next, in groundedness. Groundedness means the process of, retrieving the information. This is something like faithfulness, which means, did you answer from the context itself? Okay. Here, traditional system was 91. And OKF system was 76. OKF system was, sorry. Yeah. Traditional system was 91, OKF system was 96, and groundedness was 60. It went low. It's cool. Helpfulness. Okay. Helpfulness 0.84, 0.76, 0.93. We can see a good rise in, hybrid system, where, it is also capturing what failed, 91, 77, 92. We are always seeing a rise. Okay. We are always seeing a rise. It is not 100% accuracy. Okay. There is no 100% accuracy over here. Correctness. It is how much your answer is correct. And you can see the latency also, people. P50 and P99 latency. If you don't know what latency is. Okay. If you know what latency is, This is tokens, how many tokens were utilized. You can see less tokens are utilized over here. Okay, so cost optimization is coming into the picture. All right, and that is the whole purpose. So someone, if someone will say to you in interview how you will optimize your cost, you will tell that we will go for hybrid systems. Okay. And yes, these were the evaluations. I can of course show you the code as well. We will go to the code. Let me answer a few questions. Hybrid is extremely small standard deviation for correctness. It shows consistently accurate, doesn't very much. Yeah, almost 100% accuracy. Okay, is groundedness low? If groundedness is low, then correctness might have come from LLM parametric knowledge computation rather than corpus. Yeah. While building hybrid systems from scratch, do you have to build each different systems and evaluate then to the conclusion? Yes, yes. That is what I have done over here. Okay. I would have never shown you evaluations if, I would have never conducted this evaluation part only if evaluations were not correct. Okay. If would have failed, or maybe I would have shown you that evaluations failed. Okay. Could you please share the link to your repo? Okay, I'm sharing it. This is my repo link. We store the PDF in vector database in RAG. For OKF, where do we store the MD? So PDF will be parsed and the PDF information will be stored in MD. So once you read this, no? So see, I have given you this particular LLM wiki. This also contains how to parse multimodal data into MD files. And this particular spec.md, this also contains how to parse multimodal data into MD files. Okay. If I go here, the Cloud Code agent which was running, okay. Now let us see if it has done its job. Okay. Now let us see if it has done its job. This is wiki and this is OKF. Okay. So I will open computer vision file of wiki, and I will keep it here, and I will also open this. So see, administrative and courses is the same. I will open this and I will open this to the side. Okay. Open preview. All right. So see, we should have some change over here. Let me see, why are we not seeing some change over here? Okay. This is not, there is something which happened. Okay. Let me open this computer vision, open preview. Okay. Course code. I think there is something wrong happened. With the context, because it should not have happened like this. I will show you here. Okay. I will show you here in the other code base. Don't worry. I might have missed something. Let me show you in this code base. Here it will be clear. Okay. We have wiki as well. I tried wiki as well before the class. So that's why I was so confident that you guys want to try it. All right. And let me show you this. Okay. So computer vision, I will open preview, and OKF concepts computer vision, I will open the open to the side, and then I will open preview. Okay. Or I think we don't have to open preview. We have to open this only, Okay. Let us see. This is raw. Okay, wiki concepts AI. Okay. See, both of these differ in terms of what they contain. Okay. See, this is by LLM Wiki and this is by OKF. They both differ. How? See, I'm zooming in. Title, summary, prerequisites, related sources. Now this is amazing. This is perfect. But only for my code base, only for my usefulness. Okay. And this part, type, concept, title, computer vision, description. Okay. Tags is the main part, and source. Okay. So this is standard by OKF and this is by LLM Wiki. This is for everyone and this is for only that particular person who is using it. And yes, you can go through the code and everything as well. I will, going through the code is out of the concept now. Okay, there are three things. How do you run it, people? How do you run this particular file? You take my repository. Okay, you clone my repository. You create a virtual environment. You run all the requirement files. I have mentioned it. Then you will build the index. So to build the index, you will have Python build index. And then you can simply streamlit run. You will need some API keys internally. I will talk about those as well. Internally, I've used Grok API key, Grok model, Gina API key for re-ranking, Gina embeddings, Gina re-ranker. Okay, so you can, I've given you the repo, and life's good, guys. And yeah, one more thing. Okay, recently FDE roles are very famous. How many of you know about this FDE roles? Okay, I will just simply search. Are FDE roles a hot topic? So see how it's, yes, FD roles are currently one of the hottest and the most heavily discussed topics in tech. Originally pioneered decades ago by companies, some people adopted it, but now people are adopting it more with the rise of technology and with the speed of technology. Okay, so are FDE roles, in heavy hiring? What is that word? Active hiring. Are FDE roles in active hiring? Okay. So it's gonna say yes, FD engineers are experiencing explosive active hiring, okay, globally across India. All right. So what is FD role? So you work very closely with client environment, okay. You understand their business problems better. I'm telling you about FD roles, guys. This is very interesting. Hear me out. So how FD works is, let us say, and it is different from an AI engineer, okay. So FD role, how it works is, let us say you have some product, you have made some product, okay. Let us say you have made a product for automating business operations. All right. Let us say I am Anthropic and I have made Claude. Okay. Now you know the possibilities of Claude is endless. You can use it as a coding agent. You can use it in your workflows, and you can do it whatnot. Okay. So what I will do is, I will hire a few forward deployed engineers. Let us say I am the owner of Anthropic. I have made Claude. I will hire my forward deployed engineers. Now, forward deployed engineers are going to identify who are the potential people whom we can sell cloud. Okay, we should have a different team, but what will happen is, once we have identified that, let us say Symbiosis, okay, let us say I am the owner of Anthropic and I have identified that Symbiosis College can use my product. Okay, so what I will do is, I will send my forward deployed engineer to Symbiosis. I will ask my forward deployed engineer to talk with the domain experts of Symbiosis people, to talk to the technical teams of Symbiosis people, understand their workflow, and tell them that how you can use our product in their workflow. And again, Symbiosis is an organization. Symbiosis will have their own coding environments or own technical environments. So our forward deployed engineer will work in their environments. The forward deployed engineer will not come here. It will work over there in Symbiosis with Symbiosis teams and develop a prototype and develop something, closely work with the executives, and close off the deal right there. Okay. So FDE people are not only expert in coding, but they are also very good in understanding business problems and giving them the solutions. Okay, so these are FDE roles. Very interesting. Okay, I've been speaking to a lot of FDE people recently to explore this, because we are coming up with a course here. We are Krishna Academy. Okay, we are changing the way AI is taught in this world, and we are coming up with a dedicated course for forward deployed engineer. We'll be teaching you this particular course over here. We'll teach you, we'll also bring in communication part on here, that see, AI consulting and delivery. We'll also teach you that how do you talk to your clients. See, people might have hyped up FDE roles a lot. In the end, one line, FDE is tech consultation. Okay, I'm just gonna write it. Okay, FDE is tech consultation. Okay, sorry for that spelling, but whatever. Okay, see, if you are someone, if you are a standalone person, if you are a freelancer, okay, and if you're a tech consultation, how it works? You reach out to some client, or some client reach out to you. You discuss their problem with them, and you tell them that how you can propose a new solution. Only the difference between FDE and a tech consultation is, a tech consultant might make things from scratch for them. Okay, but FD guy will integrate the particular solution in their already existing environment, and the integration which it will do will be an own existing product by Anthropic. If you are understanding, Anthropic has made a product. Symbiosis also has a product of managing students, and this existing product and this existing product together an integration. FDs do this, and tech consultation people also do this. Okay, so in the end, it is tech consultation, but on a scale. Okay, on a higher level. So yes, this was forward deployed engineer, and please check this course out. And we are constantly, we also have an industry live batch. Just let me talk about this. We have a industry pro batch over here. Okay, projects. This is our industry pro batch, which means we make end-to-end projects over here. And now since FD roles are very much into the hype, we are also bringing up FD courses end-to-end, FD related projects, wherein we'll show some role play that how do you talk to the client, how do you develop, how do you communicate, and how do you make their solution. So we have a industry ready batch as well. So yes, that is it from my end. I hope you enjoyed this. I hope you learned the new way of organizing your information, and I hope you will start implementing this in your workflows. So that is it for this one. See you in the next videos. Until then, take care. Bye bye. Live your life.